Good morning, everybody. Can you hear me all right in the back? Yeah. Thanks so much for coming this morning. It's a real pleasure to have all of you here at the Carnegie Endowment for International Peace. I'm Leonardo Martinez-Diaz. I'm the director of our program here for climate, sustainability, and geopolitics. And the reason I'm so excited to have you here today is because this is the next chapter in a long series of work we've been doing on clean energy. Now, you may be wondering, what does a think tank that works on geopolitics and nuclear stuff historically have to do with clean energy? And the reason is we're currently in a moment where we see a confluence of three very important challenges coming together at the same time. The first, of course, is a very rapid rise in energy demand as the AI revolution takes flight and as economies around the world continue to grow. At the same time, we have, of course, in this country and in other parts of the world, an energy affordability challenge with a lot of households, a lot of American consumers and European consumers facing high and rising energy costs, and therefore a lot of affordability questions and real political issues stemming from that. And of course, finally, we have a real challenge cutting emissions, which are necessary in order to prevent the worst impacts of climate change. How do we solve all three of these challenges simultaneously? How we do that will actually have a huge impact on U.S. security, on U.S. competitiveness globally, and of course on the economic well-being of everybody in the United States. And that's why it's so important that we start to think about clean energy and what it can do to solve all of these three challenges. More than a year ago, we started a bipartisan task force which focused on U.S. foreign policy for clean energy. We brought together almost 23 folks from across the ideological and political spectrum to debate, to discuss, to substantively address the questions of clean energy and the role of the U.S. in it, both in terms of domestic policy and international. And out of that came a report that we issued earlier this year. We very much invite you to take a look at it. And one of the key findings from those deliberations was that geothermal energy is indeed a key area in which the United States can compete. And so this is the next chapter in that conversation. We want to drill down and focus more on the potential and the promise of geothermal energy. We've come to the conclusion that geothermal is a sleeping giant whose time has finally arrived. As you may know, geothermal comprises less than 0.4% of the global energy mix. It's been limited primarily by the niche geological resources where it has traditionally resided, places like Nevada, Kenya, Iceland, Indonesia. But now, thanks to some of the technology that was unleashed during the fracking revolution, there is a possibility of unlocking geothermal in many, many more places around the world. And of course, the timing couldn't be better given the real demand for firm power that is clean and zero emissions or close to zero. We believe that this administration in this country, at this point, there is growing bipartisan support for geothermal energy. We see that, for example, in the fact that the tax credits for geothermal were preserved in the IRA. We see that in budget proposals from the administration in terms of the funding for the geothermal office at the Department of Energy. We see it by the fact that the Department of Interior has expedited some geothermal permitting. Clearly, this is an area where we can have a conversation that is constructive and that brings people together across the political spectrum. The potential globally for geothermal, if it works, the next generation, is enormous. 800 gigawatts of new geothermal capacity over the next years. If these technologies succeed, that is twice the amount of today's nuclear power. And of course, we could extend this to new markets that before have not seen geothermal as a traditional energy source. You could think of places like Brazil, Vietnam, Australia, Spain, Saudi Arabia, Germany, many others that are very seriously looking at this. The climate potential, of course, is very important. This is an area that can bring lots of energy to the system and help us reduce emissions and reach many of the clean targets that many countries have set for themselves. So today we will have at the beginning of a conversation, it's not the end, but perhaps the end of the beginning, so that we can continue to engage all of you who come from many different sectors, private sector, NGOs, government, and we want to have a substantive conversation, one that is informal, challenging at times, but nevertheless constructive. And we very much invite you to read the report that is going to be, that has been released today, and the additional research we intend to conduct in this area. Let me thank some of the people who have been essential for this effort. Milo McBride, whom you'll hear from very shortly, Aislinn Familetti, who has been invaluable for the logistics and the organization of this event, Dan Helmessy, who has been incredibly important in the back office in terms of the research, and Emily Vaughn in our communications group, who has made a lot of this possible as well, and also our events and communications teams more broadly. So thank you for being here. Please keep an open mind and make sure you ask challenging questions of our panelists. With this, let me hand off to Milo, who will be giving you a quick overview of the report, Unlocking Global Geothermal Energy. Thank you.
Hello, and good morning, everyone. Thank you all for being here today. It's a great crowd, and I'm thrilled to be able to host this event and talk about this critical moment, that the geothermal energy's moment is here, and the opportunities are enormous. I'm Milo McBride. I'm a fellow here at the Carnegie Endowment for International Peace, where I work on our research for the geopolitics of energy technology, mineral supply chains, and next generation advancements. On my end, I would like just to begin with a couple thank yous as well, echoing Leo's, to the incredible research team that helped put this together, Daniel Helmessy, Devan Magalmurthy, and Deborah Go. It was just super work on all of your ends. And as well to our partners at Project Interspace for providing the GeoMap resource, which was an incredible tool to work with, and especially to Drew Nelson for facilitating that work. Perhaps a bit of background color. This research project began last summer amid this work of our bipartisan task force, when it became clear in our analysis that geothermal technologies, particularly next-gen technologies, had a rising potential to not just unleash power and heat here in the United States, but perhaps globally. And we asked that question, well, where would that be globally? What would be prime countries to consider? We held a convening in this exact room last October with nearly every branch of US government, with many leaders in industry as well as partners in the NGO space, to discuss how we would evaluate that criteria. And that has culminated into this report today that I'll be speaking on, called Unlocking Global Geothermal Energy, Pathways to Scaling International Deployment of Next-Gen Geothermal. It argues that next-gen geothermal is on the precipice of a commercial breakthrough, and then it examines the top 30 countries to consider for potential export. To begin, I want to just say geothermal energy, geothermal power today is already a global market. What you see here is a look at the geothermal power plants across the world, but developments are largely constrained to prime hydrothermal geographies like the Ring of Fire, a famous one which you see on the right. It includes countries like Japan, Indonesia, the Philippines, New Zealand, and then on the left-hand side up to the western part of the United States, Mexico, Central America, and down to Chile. There's other important resources to note. The East African Rift is especially not just promising, but has been a robust point of development, particularly Kenya's rise as a geothermal superpower. Turkey as well, and then of course Italy, the home to geothermal power plant, the first geothermal power plant built in Tuscany over a century ago. But over the past 25 years, really Turkey, Kenya, and Indonesia are driving this growth. And in this graphic here, we list out where the geothermal power development has been rising. You see that even since 2010, Turkey, Kenya, and Indonesia's growth has jumped up from pretty negligible installed capacity. I also emphasize that Central American countries, Costa Rica, as well as New Zealand, have been increasing their developments too. While the United States today has the largest installed global geothermal capacity, that is likely to be surpassed by Indonesia in the coming years. Indonesia has goals of another 5 gigawatts of development, and the industry is moving quite quickly. And this perhaps stagnant growth compared to what we would see in the natural gas sector or the rise of photovoltaics or wind has something to do with this issue of resources that I mentioned, these perfect, perhaps Goldilocks resources that exist in the right places. And there's different types of geothermal power technologies. What we have on this graphic on the left from S&P Global illustrates that the incumbent system, known as hydrothermal, takes a naturally occurring reservoir underground. It has heat and fluid and uses that steam or water to propel a turbine and convert that into electrons. That is the resource that we see, or that is the technology we see today utilized broadly in Kenya, in Nevada, and the places I mentioned. And with that, there's been a development towards what's known as a binary cycle turbine system. But across the world, there is what's known as hot, dry rock. As the name implies, these are hot resources, generally about 150 degrees Celsius, that are far more ubiquitous than this hydrothermal resource. They exist in almost every continent and across nearly every country in the world. And companies today, many of whom you'll hear from soon, are moving forward on cracking this hot, dry rock challenge. You have heat, but how do you artificially create a reservoir? And there's two solutions that are being worked on right now. The first one listed here in the center left is referred to as an advanced geothermal system. We say a closed loop system to avoid the acronym Olympics between EGS and AGS. And that technology, broadly speaking, circulates a working fluid through a sealed underground pipe to extract the heat from underneath, bring that to the surface to produce direct heat use or to propel a turbine, and then bring that back down into, as mentioned, a closed loop system. The second system, referred to as enhanced geothermal systems, or colloquially EGS, takes a different approach. And it leverages the technology that Leo mentioned from the hydraulic fracturing revolution to essentially create improved permeability in the hot, dry rock by fracturing it and developing an artificial reservoir there. Both of these technologies are moving ahead quite quickly. The first-of-a-kind projects are likely to be online in the next year, maybe year or two, which is an astounding development. Later, we'll talk about super hot rock or supercritical resources. We have a leading group of panelists who will dig deeper on that. Our view is that EGS and closed loop, AGS, are likely to compete on cost within the next decade. By the 2030s, next-gen geothermal could become very well competitive with variable renewables, as well as natural gas. What we built here is a graphic from the best forecast we could find in leading forecasters, academic literature. And what we illustrate is the dots on the right by energy technology show the levelized cost of energy today in 2025, and the dots on the left show the forecast for 2035. These are in a levelized cost basis, an LCOE, and I caution that this is an imperfect measurement of an energy system cost that does not include system-wide benefits. And just for example, as we enter a world with a higher penetration of solar, the need for dispatchable, flexible power becomes ever more important, and that is something that many of these companies are working to provide. That's to say, it's not just a baseload power source, but it can be ramped up or down complementary to renewables. And we emphasize that these numbers do not acknowledge the importance of that. But what's exciting about this is, as we look at the dotted lines, we have a lower bound thermal-fired fossil generation, LCOE, and an upper bound one on the right. Those are those vertical lines. And what you see is that the leading EGS forecast point to a $50 per megawatt hour price drop by 2035 if this liftoff happens. Other literature emphasizes an $80 megawatt hour forecast towards the end of this decade. And that is a notable point, especially vis-a-vis the competition to nuclear energy. Closed-loop systems, there is simply less literature on the subject. We cite a specific study that analyzes one of the many technologies being evaluated. Likely for some proprietary reasons, the data is not as open, but nonetheless, we could very well see cost reductions for closed-loop as well. Perhaps not as drastic as EGS, but there are important considerations to view these as complementary nonetheless. With regard to water demand for next-gen geothermal systems, as we enter a world of greater levels of water precarity, it's a consideration we note. There is a narrative that has emerged that because one of these technologies requires hydraulic fracturing, well, maybe it will be deeply water intensive, like what you would see out in the shale patch in the Permian. From this analysis, though, we find that EGS has increasingly lowered its water use. The graphic listed here is in gallons per megawatt hour, and we compare this in the dotted lines to natural gas and nuclear water demand, again in gallons per megawatt hour. The past decades of EGS trials presume that it would require significant quantities of water on par with that nuclear power demand. But increasingly, the reports from industry illustrate that actually it's coming down quite quick. Advanced geothermal, the closed-loop system, requires really negligible amounts of water. Some of it will be needed in the actual drilling process, but the closed-loop system offers what's an interestingly water-resilient technology in a world perhaps facing greater levels of water stress. And again, emphasizing that these two technologies have complementary trade-offs, that both of which are important to unlocking a globally ubiquitous geothermal power source. The next-gen geothermal scale-up being presented by leading forecasts is astounding. This graphic we looked at shows that under a geothermal liftoff, installations could jump 100-fold. Here we blended data from the International Renewable Energy Agency, from the US Department of Energy, and from the International Energy Agency's report, The Future of Geothermal Energy. And we really emphasize the folks in the room to check out these pieces of research. They are fantastic, and we're grateful to have the IEA here in the room, perhaps to speak more about that. What we did is we looked at how much installed capacity from the year 2000 to 2009 does the geothermal power industry have? About 300 megawatts a year. It's quite small. But under these forecasts, under different scenarios, the DOE one being slightly more bearish, we could see between a jump of 20 to 60 gigawatts of annual installed capacity. This is a step change for the industry. And while a huge opportunity, something we mentioned in the report, and a place we hope to deliver further and more granular research, is what this means for the supply chain. There are three essential components of building a geothermal power plant. I'm simplifying here, but the drilling rigs required to drill the wellbore. Some of these rigs can be used from the oil and gas sector, but not all. They likely require a heavy hook load. This is to access deeper depths. The second component is the casing material to seal the well. Much of this is very transferable from the oil and gas sector. There are questions about the size of the wellbore between conventional or unconventional oil and gas wells and a geothermal well, but the materials nonetheless have some substitutability. And lastly, there is the above surface question of turbines. These do not use the conventional natural gas turbines. These use what's known as an organic Rankine cycle turbo expander. It is a relatively niche industry. There are basically 5 players in the world, 1 domiciled here, 3 domiciled in Italy, and another domiciled in China. Critical questions could emerge about the turbine market as it scaled. We had some interesting talks with industry about whether this could create opportunities for other types of turbines to seize this market, or whether legacy natural gas turbine players would become players in the organic Rankine cycle system. This is all, of course, early and speculatory, and a place I'm keen to research further. Today, EGS and closed-loop systems are largely a North American story, but with global potential emerging. In this graphic here, we map several projects emerging at various stages, ranging from pre-feasibility to actually first-of-a-kind commercial demonstration. And we see that projects are underway not just here, but in Turkey, in Romania, in the Philippines, and in Germany. And some of our panelists today are working on those projects. But what the graphic illustrates is unsurprising. The cluster of these next-gen developments are really concentrated in this neck of the woods here in North America, and particularly in the United States. And there are several reasons for that. The first is, of course, just the scale and the excellence of the US oil and gas workforce, its expertise not just in the subsurface, but in drilling complex holes and related infrastructure projects. That's a unique labor force advantage that the United States is likely privy to. The second is a robust venture capital ecosystem and related innovation pipeline that has helped bring some of these technologies from early stage to where they are today. beginning to put steel in the ground. And lastly is the question of demand pull. Leo had mentioned we are amid a decade changing of electricity demand today. And the data companies, big tech companies, are proving to be interesting first movers in helping to stimulate some of the first-of-a-kind projects. And I'll end also with saying that the national security community, the United States Department of Defense, has also been interested in helping building these technologies up on US military installations, given their unique opportunity for an energy-secure, non-fuel reliant source of both heat and power. Those are some of the many dynamics we highlight. But what are the optimal places for export? And that's the core question of this report. Carnegie's report measures the 30 top potential countries across 7 indicators. And the first one is resource potential. And with that, we had the absolute pleasure of using the data from Project Interspace's GeoMap. And for those not aware, it's an incredible tool, an interactive geospatial tool that allows you to go around the world and see where this hot, dry rock resource exists. With that data, I extracted it and created a rating system by country to ask 4 critical questions. 1, what is the total sum of that country's hot, dry rock resource? 2, what is the sum of that resource by landmass? And that's to create a weight for smaller countries and to acknowledge their potential as well. And then 3, what is the upper bound potential of that heat resource? And that's to say, what's the highest heat gradient, which in theory could prove a more economic place, especially for a first mover to go. And 4, we also addressed that upper bound heat by landmass and created a rating system, rated those countries, and came out with this list. That list has countries that are not included in our analysis, countries with high levels of political risk, high levels of investment risk, or foreign entities of concern, where in this decade scenario, it would just be very unlikely to see an American startup doing a joint venture with. So we removed those countries just for the accuracy's sake of this study. The second question we ask is, where else has onshore oil and gas activity? We looked at the Baker Hughes drill rig count data to ascertain where there is active onshore drilling. And that's not to say it's a fully transferable level of expertise, but it's just to say, would you have a place perhaps where there are casings, a labor force with subsurface knowledge that could help stimulate this? And third, we looked at geothermal power developments over the past 15 to 20 years with data from the International Renewable Energy Agency, basically ascertaining who in this time frame has been scaling up geothermal power. This helped us to see where among the incumbent players strength could exist, where a transfer perhaps would be more logical. And then lastly, and a big thanks to our incredible research team, we scraped the internet for these 4 other indicators. You could break them down by policy regime and demand pull. On policy regime, we asked, does this country have subsidies, feed-in tariffs, contracts for difference in the power market, but as well de-risking measures for drilling? This is an often underlooked but essential area to ensure that geothermal projects can be actualized. Perhaps insurance measures, among other ways of ensuring that if a drilling project goes south, all is not lost for a small company, let alone a startup. We also looked at geothermal permitting regimes. We read through the legal documents of these countries and creating a rating system basically to ask 3 questions. 1, does this country have an existing geothermal-friendly permitting regime? 2, does it have a geothermal agnostic regime where you could see it being somewhat amicable and working within? Or is this a country that has nothing in its legal text specifically for geothermal? And lastly, we looked at demand pull indicators, data center build-out, and district heating. With data, we asked, does this country have a hyperscaler or hyperscalers en route or a gigawatt plus of data center capacity in pipeline? As I mentioned, big tech companies are proving to be some of the first movers in this, and it'll be interesting to see if that permeates beyond just these projects in the United States, but as a long-term trajectory. And lastly, we looked at district heating. These are not ground source heat pumps in your home. These, of course, are these large-scale, generally thermal-fired heating units that you see largely across China and Europe that provide heat in the winter for entire neighborhoods. This as well is becoming a first mover, particularly in Europe. One of the first projects of the closed loop system, the first project, will be specifically building for district heating use. These are an imperfect and unfinished level of measurements. We emphasize there are a couple details that should be considered in future research. The first is that the resources we have from inner space are the best out there and the benchmark. And as more exploration happens, more resources could be discovered. So this is not finite, and my understanding is that new exciting things are on the way. Secondly is that the look at where these resources live, we triangulated with what we viewed as the key economic and industrial clusters in that country. Say, is a resource located near power demand. We did this qualitatively in the report, and you can read further on that. But we don't take into certain local considerations, say for community benefits, water rights, that are obviously important to ensuring equitable development of large infrastructure projects. Third, we did not include direct use heat, which is also an important consideration for industrial sectors that can have this opportunity for heat use. And we emphasize that as a place to look for going forward. A brief overview of our findings. We have three categories that we came out with. The first one is known as the power players. These are potential prime early adopters. They're markets with both strong resources, but also incumbent geothermal activity in the power sector and large levels of geothermal policy support and simplified and clear geothermal permitting regimes. We also see many of these countries having significant quantities of data build, and some of them having district heating as well. There are some of the usual suspects here. Turkey, Kenya, Indonesia are all listed, unsurprisingly. But Germany, which uses geothermal for direct heat use and is building some power plants, comes out quite strong across all of these measures. Similarly, Mexico, Chile, both of which are not necessarily known for this, really come out strong as well. Mexico has about a gigawatt of installed geothermal capacity, but it hasn't built anything for the past 15 or 20 years. There's strong resources. There's a strong consideration given power demand, industrial data demand in Mexico, and President Sheinbaum has recently moved forward on considering the importance of geothermal in this region. Similarly, Chile just built its first geothermal power plant, but has both strong resources, goals to retire its entire coal-powered fleet, and enormous growth of variable renewable energy, where clean, firm power could be a resource. And as I'll mention later, Chile's proximity to Argentina's Vaca Muerta shale region could be something to note as well. The second category are the second movers. These are potential markets to consider. They have strong indicators across the board, but many are new to geothermal power. The caveats here being Costa Rica and El Salvador, which do have significant hydrothermal development in comparison to their load, but varying levels of policy support, coming out slightly more bearish on that. Costa Rica in particular, though, is interesting, not just because of its data center build, but because it's becoming a chip manufacturing hub for Central America, another heavy source of electricity demand. Many European countries come out quite well here. France, Spain, Romania, and Hungary. And in the analysis, we described the varying trade-offs. France is really focused right now on direct heat use and not on power. And that is logical, also given that France is this world-leading nuclear capacity of clean, firm power that already exists. Nonetheless, there's decent levels of policy support, and there's also an interesting legacy research goals of trying to also unlock EGS, but didn't quite work out, so to speak. Spain, on the other hand, has some really interesting opportunities. Spain doesn't have a geothermal power plant today. The Canary Island is building their first one, but has a notable opportunity given its power market dynamics and its goals to shutting off renewables. I'll start to move a little bit more quickly through this. Just emphasizing that Australia comes out quite significantly, high levels of oil and gas production, good resources, and as well an EGS feasibility study underway near Canberra. Colombia, too, comes out quite strong, and a synergy I find of interest. Colombia's state-owned oil and gas company, Ecopetrol, has begun developing Colombia's first geothermal power plant there, which, again, this synergy between oil and gas is an important one to highlight. I'll end on the heat on the horizon. These are longer-term considerations, countries that really don't have the indicators yet, but have resource potential, and many of them have important and impressive oil and gas industries. I specifically call out Saudi Arabia, which on the western side of the country, near some of the industrial clusters like the Yanbu city, are well positioned, and given Saudi's excellence in oil drilling, its well-capitalized sovereign wealth fund opens up some interesting dynamics. Lastly, with Argentina, a country whose investment climate is quite difficult, and we emphasize and caution that in the report, it is home to really the second largest fracking revolution in the world. Again, the Vaca Muerta play in the western region of the country, where you could see a higher level of transferability as opposed to conventional production. My apologies, slide behind. Just a quick outlook of our final findings of the countries we looked at. This is non-exhaustive. Other countries should be considered and emerge and included as new resources and new conversations emerge. But we hope this can be an important first step in thinking about where next-gen sources have opportunity. And lastly, I'll end real quick with our policy recommendations before turning to the panel. I want to acknowledge the timescales of this. The first-of-a-kind next-gen projects are being finalized right now. This is a decadal report that envisions a scenario where, as these become bankable, they can be diffused across the world. And in the meantime, we highlight an all tides lifts all boats approach, that is to say, continue geothermal policy right now for incumbent production and use that momentum to blend in the next gen as the opportunities start to really emerge. 4 recommendations for countries interested: align policy frameworks to unlock this potential. Governments should introduce clear market incentives and integrate geothermal into their grander energy strategies. They should coordinate with industry, especially oil and gas industry, if it exists. And they should draw on support from international leaders to accelerate development. We highlight a couple examples of the report, but the most famous one is Iceland's technology transfer to Kenya in the 1970s and 80s with the assistance of the United Nations. That today Kenya is a geothermal superpower, providing 50% of its electrons from geothermal energy, and an important point of collaboration to highlight. Secondly is to build global partnerships and to expand geothermal knowledge and supply chains, strengthening IEA engagement with emerging markets, elevating geothermal in COP forums, which has been sorely neglected. We saw at COP28 a nuclear power pledge, and that's great to see, but the types of actors that could be drawn in here across emerging markets and the OECD is a significant one. And lastly, the diversification and building out of supply chains to share capacity and resilience. Third, to renew multilateral financing tools for next-gen geothermal. The World Bank's Global Geothermal Development Plan is slated to be revamped, and that should be done so to include next-gen technologies in its provision as these later come to market. Also thinking about updating risk-sharing measures. I mentioned risk mitigation techniques for drilling, but also crowding in capital from sovereign wealth funds, from export credit agencies, and beyond. And lastly, we are here in the United States, and there is, of course, an opportunity for the U.S. to strengthen its overseas strategy to boost global leadership and to diversify opportunities for its oil field servicing industry. The U.S. should scale up early-stage support through likes of USTDA, deploy innovative risk mitigation instruments, and embed geothermal into its diplomatic platforms, ones of political durability, perhaps Quad, perhaps PTEC, and more. So I thank you all for this time. I hope you enjoy this report, and I'm thrilled to welcome our first panel today, thank you.
Thank you, Milo. Welcome, everyone. While my panel makes their way to the stage, it's a great honor and pleasure to be here as we get ourselves settled in. I'm Vijay Vaitheeswaran. I'm the energy editor for The Economist, and it's my great pleasure to be your immoderate moderator for our first session of what will be several, I think, fantastic sessions. And this one discussing the new American drilling revolution. which is next-gen geothermal. So let's see. We have some leading firms in this area from the next generation of geothermal, as well as an expert here visiting from overseas. And I'll introduce them, starting with my right. Rebecca Schulz, geothermal lead at the International Energy Agency in Paris. Lev Ring, president of Sage Geosystems. Caity Smith, director of stakeholder engagement at XGS Energy. And Rob Klenner, president of GreenFire Energy. Please give them a nice round of applause to get them warmed up. And speaking of warmed up, some of you who are more numerically astute may have caught from that excellent presentation that we had this morning from Milo that the share of geothermal energy today is not that far off from absolute zero, right? It's pretty small. But I want to take some inspiration from that as a starting point. I want to quote these words from Lord Kelvin, Mr. Absolute Zero himself, from 1897, who said, "The internal heat of the Earth represents an amount of energy which exceeds by many times the energy derivable from all the coal deposits of the world." And so more than a century on after his prediction, or his observation really, we are here reflecting on what to do about this. And interestingly, it is a moment in which there is movement, innovation, activity, exploration, and potential. And so that's what we're here to dig into. A terrific report on all of this has been laid out by the IEA, which I recommend to all of you. And so I want to turn first to Rebecca. Your analysis argues that the cost of geothermal can fall 80% by 2035. How are we going to get there? Give us a sense of the sweep of what's possible and what these hardworking people to your right need to do in the next 10 years to get to some of these more ambitious targets.
Yeah, so maybe I can set the scene a little bit.
Please
and
do.
then everyone else can jump into what's happening in the real world as well.
Exactly.
So in December 2024, the IEA released its Future of Geothermal Energy report, and it was commissioned. It was asked by by Hungary, who is president of the EU Council. And what we looked at was really looking at what is the state of systems today. So where is the innovation happening across sectors? How could that be applied to geothermal? And then what comes out of that? And what we saw, and Vijay stole my thunder already a little bit, in terms of conventional geothermal, and quite frankly, and Milo laid it out really brilliantly, and congratulations, John, on a great report. Conventional geothermal is extremely limited in where it is available. And when we look out in our scenarios, out to 2050, it's near zero to begin with, and it doesn't get much above that in the next few years. But when we start looking at the innovation that has happened in and around, in the United States, in North America in particular, in unconventionals and oil and gas, and the overlap between oil and gas and geothermal, what we estimate is that there is about 75%, if we look at these different types of geothermal that Milo had described, that we can drive down the cost by about 75 to 80% if we have a high amount of learnings transfer from the oil and gas industry across to geothermal. And that's astounding, because that starts to put it in the range that Milo was describing earlier. What we need to do in order to do that, though, is really to leverage the industry and the skills of the people that are working in oil and gas and geothermal today. And so we estimate for every dollar that is spent on geothermal, there's about 60 to 85% that actually overlaps with the oil and gas sector. So there's largely a one-for-one. You can pick a lot of it up and put it across into geothermal. And that's happening, I think, in spades in and across North America. And what we'd like to see happen is how can this actually grow? So if that happens, then we start to see that we grow from not just 1% of geothermal. We start to see that actually by 2050, it's up to 15% of geothermal power generation. And beside that, it's not just power generation, it's also heat as well. And so the opportunity for geothermal is really, really substantial.
So one of the points you've emphasized, and we've heard a couple of times today, is that this is not your grandfather's geothermal, right? And this is something different, something new under the sun. And it bears repeating that there are lot of interesting transfers in technology, and you emphasize, Rebecca, also in human know-how and skills that can come from a very well-established, well-capitalized industry, the oil and gas industry. And in particular, the fracking technologies have been emphasized, but other skills as well. And I'm very pleased to turn to my next speaker, who is an example of such a crossover. Not the only one on stage, by the way, but certainly the first one, and maybe the one who has the most experience, because we were talking about it a little bit yesterday, of having had a foot in both worlds. So maybe pick up a little bit on this as you tell us a little bit about what your company does. Help us understand the technology, because it may be unfamiliar to a lot of us in this room, but also how you see that bridge from the oil and gas to the new world.
Right. And as Vijay and Rebecca mentioned, geothermal is very small today. But if we go 20 years ago and look at unconventional oil and gas, it would seem like a stupid idea to produce oil and gas from shale. Okay, and look where we are now.
That's what all the big oil companies said at the time, right?
And we at Shell said exactly the same.
Right.
I was there, so yeah. And so the limiting resources becomes unlimited if I'm saying geothermal resources becomes unlimited if you can engineer reservoirs, and as Vijay said, the deeper you go, the more resources you would have. So there are two challenges: combining harvesting heat from depths and also creating artificial reservoirs. So Sage, we started, and the unique about Sage, we're pursuing what Milo classifies as an enhanced geothermal system, EGS, building artificial reservoirs, and we're using proprietary frac down technology that we brought from our oil and gas fracking operations to, instead of drilling deep, we're fracking deep. And that allows us to harvest heat, and also we recover not only thermal energy, but also mechanical energy that allows us to build not only geothermal power generation, but also develop long-duration energy storage facilities.
Well, you snuck something in there right at the end that's a new idea. And so maybe I'll unpack it a little bit, and we can pick up on this as we go along. That is, so far we've talked about geothermal as a source of energy that can be certainly applied to generate electricity. That's an obvious application, as well as the heat, you could imagine. District heating was mentioned by Milo as one of the things in Europe and other places that it's being used. But this is another application of this technology that I'm hearing from Lev, and that is, you could imagine a giant battery, basically, of the sort that we have with compressed fluids already in existence. And that gives another use case, another financial flow, maybe another advantage for the power grid, for example, as a complementarity to solar or wind intermittency. We can unpack this a bit further as we go along, but I didn't want your comment to drop without a little bit of explanation. I hope I got that right, Lev?
Yes, absolutely.
Okay, great.
Yeah.
So we'll pick up on that as we go along. But the thing to bear in mind is that we're not comparing screwdrivers to screwdrivers, right? We're comparing sort of a multi-purpose Swiss Army knife, potentially. Now, admittedly, one that's maybe a little bit out of reach at the moment and a little expensive, and maybe you'll never get there in the way that people dream. But one has to keep in mind there may be multiple advantages to this sort of technology, including being a baseload technology and also a flexible technology. That's a little bit hard for us to wrap around our heads in terms of conventional energy thinking, or indeed the way that markets reward companies. We may need to think about how we regulate these sectors in a more supple or agile way. But we'll get to those things in a moment, but that's just to put a marker down. Caity, let's come to you. Tell us about XGS, and now you take a different approach from what we've just heard from Lev. So tell us just a little bit about it and what you see as maybe the possibilities or advantages of how you're doing it.
Yeah, great. Thanks, Vijay. And thank you to Milo and the Carnegie team for putting all of this together today. It's great to see a full room here to learn more about geothermal. So XGS Energy is a next-generation geothermal developer. We are looking at a closed-loop system, so that AGS from the alphabet soup that Milo mentioned earlier. We've developed a technology stack that allows for geothermal development that's not dependent on water or geology. So it's,
You use
really,
only pixie dust.
yes.
No,
This is
tell us more.
this is my magic wand.
Exactly. No, tell us more. Tell us more.
Yeah, so we have developed a patented technology that we call thermal reach enhancement. I will refer to that as TRE because it's a lot fewer words there. But so this allows us to capture up to 30 to 50% more heat from hot rock. So XGS has designed a single wellbore system that's a pipe-in-pipe system with very simple well geometry. We're just drilling straight vertical wells. So, a little bit lower drilling risk, a little bit lower costs. We don't have to do some of those long horizontals that you see in some of the other next gen. And then, we use our thermal reach enhancement in the cement that holds the casing in that helps us to pull that additional heat out of the hot rock. So, we're really looking at a solution that addresses kind of that false choice that many regions face when they have to choose between energy security and water security. I think Milo's slide earlier that showed the different water usage, it's really exciting to see, some of those dropping for EGS and so forth. But with XGS's technology, there is zero consumptive water use once the wells are drilled. So it is fully closed loop. There's no interaction of the working fluid with the natural environment. So there's lower environmental risks. So just lots of exciting things there that we can dive into.
Of course, very clear the advantage in terms of not needing ongoing water use, groundwater depletion. But you do have a very different pathway than those that have taken the path of using the fracking technology, multiple drills, as it were, pipes. And so that may have its own advantages and disadvantages in terms of complexity or cost or materials. We can get into that later if people are interested. But it's a different bet, and that's the thing to keep in mind with different advantages, different pros and cons. Maybe we can talk to you, Rob, about your green loop technology, I think you call it, right? Give us a little context. Your company's a little different. There may be cats, you might be a dog, in the sense that you have a kind of a rich uncle in the form of one of the world's biggest oil services companies as an important shareholder, Baker Hughes. Tell us that provenance, but also how that informs the technologies that your company is pursuing.
Yeah, so even just to kind of give you a little bit of background, I'm a geologist, and pleasure just kind of hearing everything Milo was talking about and all these different technologies. One of our approaches is really the geology dictates the right technology we're going to apply in the subsurface. There's the kind of the green loop technology. We've deployed that in existing assets, so working around Asia Pacific, but also in the US, where if you're familiar with oil and gas, enhanced oil recovery, how do we take these existing assets and do more with them? So low risk, we know the heat source is there. When we start to move out into other areas, how do we start to look at more enhanced geothermal systems, or even a combination of enhanced geothermal with closed loop based technologies? So again, with kind of the oil and gas industry, you have the oil sands, you have shale, you have deep water. All these wells have different completion designs, different drilling designs, and really it's how do we maximize the most efficient way to get the hydrocarbon out of the ground. We're doing that in a similar manner with heat recovery. So several different projects where we're looking to be more behind the meter or co-locating with actual where the energy is needed, providing a premium power supply that's theirs. It's really a private power 24/7. It's always available. So kind of couple different opportunities we're looking at on greenfield development, but also brownfield. Where do we apply the right technology, and how do we maximize heat extraction out of the resource?
And talk to us just a moment about how, again, having that close legacy connection to oil field services and the oil industry, how does that affect some of the choices you make, whether it's manpower or access to technology? How much does it help? And equally, it's a conservative industry. It has its own risk and rewards that are different from geothermal. Could it also be a hindrance, maybe? Give us a flavor of the challenges you face.
Yeah, so maybe kind of going back to the other questions you've asked the other panelists. So one is the people are very important on getting the right people. I couldn't be more proud of the people I have around me. We moved the location to Oklahoma City. So if anyone's familiar with Oklahoma City, really kind of the birthplace of where the shale revolution took off. Lots of great people there. Unfortunately, as we just got better harvesting this resource, you needed less manpower almost over time. So there's a lot of people, what I say, on the bench there, not just reservoir engineers or drilling, but even I've hired some people on the business side that just get the subsurface, so it's easy to talk back and forth. Kind of going back to your other question now on service industry, I think that's where we have Baker Hughes and Vallourec, H&P. They're part of investors in us. The great part is just the innovation again. So of course, we're not an oil and gas company. Things are very expensive, right? We're doing a lot of these one-offs. I think that's where, similar to as the shale took off, innovation really took off. You had a lot of people come in, modify things, and we know we have the technology, but it's the engineering resources within those divisions. How do we start to take that and cater it to larger diameter, well bores or harder rock? So there's some consideration in engineering that needs to be done there, but it's there and available. It's really kind of the market and where it's being driven on how they allocate those resources. So again, for us, it's as we start to scale, if we get to this point of scale and bringing down costs, when we go out to do a field job, you're really only talking to a couple vendors sometimes. So we really need to have more vendors out there that are competing against one another, helping us drive down those costs, the manufacturing and scaling those. So as we start to scale and provide that market demand, we're going to have a lot of new suppliers in the market that are going to help us compete on costs as we start to bring these down.
Great. Well, you've emphasized the financial aspects. It's a good pivot to the next part of our conversation. That is how's this going to be funded? Show me the money. Rebecca, let's come to you.
It's such
the IEA's report talks about, again, the projected pace of growth of the sector. We could see $140 billion in investment by 2035, if I read the numbers correctly. Yet the numbers I added up on private equity investment so far is only $1.2 billion in 2023. Again, it's going up, but we're talking 100x plus increase. So where's this money going to come from?
It's a great question, Vijay. And I think also just reflecting on the geothermal industry itself, because the geothermal industry has both the components of oil and gas, in some ways the riskiness, because you're still doing these exploration production activities, and also the power markets. So I don't know if anybody in their country or their hometown trying to get connected to the grid these days is not so easy. And so you end up having, even though the resource is largely everywhere, to different degrees and different sources, there is still risks to this, risks to somewhat to the subsurface, and also then risks to the overall development and project itself as you go about the permitting cycles of those two key pieces. And so when we're looking from a company perspective or an investor perspective, that risk reward is quite difficult. And I think Milo may have said it really eloquently earlier as well, that when it comes to geothermal, it has these specific advantages in terms of being able to be potentially either baseload or dispatchable. And that, hopefully, if we look at a policy perspective, we can look at how that could be assessed at a premium. And then additionally, when we start to look at moving into the future, and I think if we look at the 2024 numbers for investment in geothermal, actually the geothermal investment has really ticked up quite sharply. So I think we'll be happy to share those numbers shortly as well. We also need to understand, are there similarities between, say, the oil and gas sector and the geothermal sector with respect to reserves-based lending? So in the oil and gas sector, you assess resource and potential. That's done through reserves assessment. But that doesn't really exist for the geothermal industry. And so if you're an investor wanting to go out and you think geothermal is a great opportunity, it's clean, both sides of the all sides of the ocean. are really interested in this. How do you know that what you're actually investing into is what it says it is? And so I do think there's actually a good bit of work that we could be doing of describing what is the potential, how much do we think it can actually produce, and then combining and bringing in the financial investment community of how do we actually describe this in a way that we can make it more marketable, more market-driven.
Lev, you've heard the overview from Rebecca. I've mentioned the figures of certainly of private funds, venture capital. Do you think venture capital is a fit for purpose for scaling up the sector, like many other startup sectors we've seen? Or do you have some challenges there?
So let me answer your question, but slightly differently. There is no lack of VC capital or development first of a kind capital to develop technology. There is no capital to scale it up, as Rebecca said.
Right.
Okay, it's just huge gap that is difficult to fill. Okay, now we're all as an industry working with data company. We have a tremendous support from U.S. military, from Department of Energy, so there are efforts, okay? But to get to this scale that you are referring to, okay, 100x, okay,
Right.
this valley needs to be breached, okay? And that's what Rebecca is talking about.
Your own company, you have VC backing.
Right.
What is your plan to go from N of 1 to N of 10 to N of 100? Private equity, bridging capital? How do you get to that, bog standard project finance where the guys on Wall Street will just sign off without even worrying too much about your company? What's it going to take?
So we signed offtake agreement with Meta for 150 megawatts. It would require roughly close to $1 billion investment. But because we have off-taker for many years, funding organizations, private equity funds, more than banking sector, is interested to help to make it happen.
So having a commercial off-taker, obviously Meta is a credit-worthy off-taker. That's a credible buyer in the way that the big tech companies in effect created the renewables market in the US through PPAs, moving in early, creating bankability for the developers. That's an early hint of what you're seeing. Am I right?
Yes. And I want to make one comment to what Milo said about countries that grow quickly, geothermal power generation. It's conventional, but example is very clear. If you take Turkey, okay, why Turkey have grown like gigawatt in the last 10 years? High offtake tariffs, guaranteed, very easy interconnection, government provides interconnection, and workforce and oil and gas infrastructure. So all these three components, okay, skilled workforce, easy to interconnect, and guaranteed high offtake tariffs, that makes geothermal industry to get to the scale that we're talking about.
Right. Now, the first two people can observe, work on, improve. Saying that just give me a lot of extra money, that's not going to fly in the US, I think, unless, and here I'm going to come to you, Caity, you have a rich green uncle in the shape of, let's say, the big tech companies who are willing to pay a little more now for either their green credentials or for the innovation potential or to lock in power at a time when the grid may not be able to deliver it. Can you tell us your experience with the financing question we're talking about, and in particular, any interesting financing options?
Yeah, so similar to what Lev was just saying, XGS recently announced a partnership with Meta for 150 megawatts of geothermal power in New Mexico. So, having these...
Lest anyone think we're being sponsored by Facebook or anything, Google has also invested in a competitor that's not present on the stage. I feel the need to disclose.
Yeah, and I think all of the big tech companies and hyperscalers are looking at geothermal. Meta has just kind of been the front runner and first to announce these deals, outside of the Google deal in Nevada. So, I think these Meta partnerships and other hyperscalers really show geothermal's unique role as an infrastructure enabler, so not only do you have that, guaranteed offtake agreement, but you also have that added capability of, you're building a larger infrastructure that is going to be creating jobs and economies, funding for different economies, local, because geothermal is a 24/7 baseload energy source, it allows data centers as well as manufacturing to really be located anywhere, not just where there's potentially good solar or wind resources. And so, that geographic flexibility is really crucial for national competitiveness, not only for geothermal energy, but for the tech companies as well. So, I think that we have a lot of the same, I would have a lot of the same answers as Lev had regarding the financing.
Well, let me throw a curveball at you. One of the
Yeah.
audience participants, and thank you for your questions. I'm monitoring them on this little iPad over here. Asked, given all the wonderful things y'all are saying on stage, why is nuclear getting a lot more attention than geothermal, including from the big tech companies? How would you answer that?
Yeah, I think, and this is maybe a little bit off script. We like to say in geothermal, we don't have a technology problem, but we have an education problem. So because geothermal and hydrothermal has been so geographically limited for the life of the geothermal industry, not everyone knows what geothermal is. There's also very high upfront risks and costs that some of those are changing with next generation technologies. But people know what nuclear is. Nuclear is a big word everywhere in the world. So when people in some of those second tier countries that Milo pointed out earlier are talking about energy options, geothermal isn't front of mind for them because we aren't out there as an industry loud and talking and bragging about what we can do. So I do think that as we saw in the final One Big Beautiful Bill, geothermal and nuclear received very similar treatment. The current administration is very supportive of geothermal. I do believe that the president's executive order on energy dominance may be the first time that geothermal was actually mentioned in an executive order, which is very exciting. I've been in geothermal for a long time.
So happier days are ahead for geothermal, based on that.
Yeah.
Okay.
Let me give you a slightly different angle, okay?
Sure.
And maybe a little bit controversial, but
Please do, if you can.
so nuclear does exist today at scale. When you take France, whatever, 60% is nuclear, okay? So there is no question today if nuclear is scalable or not, okay? And because it has been implemented, technology risk, there are other risks, but technology risk, very small.
Yeah.
On the other hand, today geothermal does not exist at scale, even conventional hydrothermal. And so it's an old industry, it's 100 years. And the reason is it always was high risk as far as drilling for these hydrothermal resources and getting out what exactly you were promised to do.
Right.
And so when you come to a banker, bankers don't distinguish old geothermal or new geothermal. They just say, okay, geothermal is high-risk industry and returns are not high enough to justify taking these risks.
Right. So that's a mindset.
Right.
And technology is advancing. Actually, Rob, I want to come to you on this because there is a question here about the kind of data and that's being made available by technology. To Lev's point, with the next generation of geothermal technologies and the new seismic and the new tools that we have with advanced drilling knowledge, how much do we need to update our risk assessment models, and not just at Wall Street, but more generally of the riskiness of these technologies going forward? What do we know from the early pilots or first wave of projects? And how does it affect our predictions on the cost curves as we think about, of course, where the rubber hits the road is on the cost of the power delivered.
Yeah.
How do you think about that? And maybe Rebecca, I might ask you to follow up on that.
Well, it's a good question, and something every once in a while we always talk about geothermal everywhere, right? And I think we kind of have to remember, someone may call me up and say, hey, I'm in North Carolina. What can you do for me on a geothermal side? And I kind of have to politely say, hey, we're not interested in developing geothermal on that part of the country yet, just because of the temperature gradients are not as favorable. So still, you may have you're just going to have a large overall risk there. Where we're trying to move from a risk standpoint, especially our companies, we're working in areas where we know or working close to what they call known geothermal resource areas. If we're going to go somewhere, we're going to start where we know the resource is there, it's hot.
So start with a sweet spot.
Start with the
technology.
sweet spot. I mean, it's
Right.
no different than what the shale industry did. If you look at the Bakken of North Dakota, they started on the Cedar Creek anticline and just kind of built there, and then they stepped out appropriately. So we're taking that approach, work on the sweet spots. At the same time, it's, there's not as much information as you said. So using the latest and greatest on geophysical surveys, de-risking that, but eventually you're going to have to go and drill a well. That's where, and we're talking to the gentleman here, how do you start to de-risk some of that process as we do exploratory drilling? I know other countries offer, if you don't hit the resource, they cover some of the costs there, right? So more exploratory drilling, more data and information.
That's not available in the U.S. for you.
No, not
You don't get a insurance policy from
No.
the U.S. government or taxpayer.
No.
We
Yeah.
have in the past, though. In the 1980s, DOE had a geothermal well drilling risk mitigation program. So it'd be great to see that come back.
Well, that's a policy question. Let's turn to Rebecca. What do you think about policies that deal with the risk? I mean, we're being a bit cheeky here, but the more serious question is clearly capital expense. It's a capital-intensive, upfront kind of investment, and the risks are clear, although they're different than their risks in oil drilling or other kinds of investment. So, is there an argument for some form of public policy intervention to provide risk insurance, or do you think this is something that companies can pool together, or private sector mechanisms can provide that?
I think there's potential. I think one thing, and I'm going to build on what both Lev was saying earlier and Rob as well, is this next gen geothermal is not, it's not your grandparents' geothermal, right? And so it's explored in a different way. It's explored much more similarly to conventional oil and gas, because a lot of these are sitting in sedimentary basins that we've known for decades, centuries. And I think in this case in particular, success begets success in this. So the more that we have companies out and moving forward and being successful in this, I think it helps to create an understanding that this is not the same thing on one side of the aisle or the other. And then moving ahead in terms of the overall risk assessments that you have, next generation geothermal is not necessarily having the full level of risk of oil and gas itself, right? Mm-hmm. So your largest risk, because I am perfectly confident that these companies can go out and they can drill those wells. In most cases, their little geomechanics can be a little tricky, but they can go out and they can frack those wells. What we know less today is, can we actually keep those wells producing for a long period of time? And that's very different than conventional geothermal.
Is that because of more hostile temperatures and pressures, or what's the uncertainty? Why do we not know that?
Yeah, well, in part it's because a lot of the work that's been done, a lot of the projects previous to the last few years, they didn't have the advantages of the unconventional shale, unconventional oil and gas boom.
I see. So this is all very new. We're applying them now. You want to
Right.
jump in, Lev?
And let me add to this your question. So in this new generation of geothermal, we have what is called thermal decline, okay? And it's piece of the physics. You cannot avoid it. Mm-hmm. The same is actually in oil and gas, different nature. It's not thermal decline and resource decline. But in oil and gas, it has been well qualified. When you plan to drill a well and you have reservoir analysis, you know how long you're going to produce and what is your decline curve. In geothermal, it hasn't been proven. It's only modeled. So if risk of drilling and reasonably small and financial organizations are ready pretty much to accept them, what they don't know long-term performance.
Right.
We are getting 20 years PPA, and PPAs, and there are no historic record how this
So you need a track
track record.
Right. And just to clarify for everyone, as I understand it, the temperatures we're dealing with for the range of companies and technology we're talking about in this panel is 150 to 200 degrees Celsius. That's different from the panel that's going to come a bit later, the super hot panel, where we exceed 350 C and really get into much more questions of metals integrity and pressures and so on. So you're sort of hot, not super hot, if I can call it that.
Nothing very different from oil and gas industries.
So it should be doable, and
Right.
the model should be right. But you still have until someone will put money behind it. They want to see you actually do it. I get it. There's one other technical question I wanted to get to from the floor, and this one's really for you, Rob. Before we move to talking about international cooperation opportunities for expansion overseas, and the question asks about. Can dried up oil wells be converted for geothermal heat or power generation? Now, that's a very specific way of saying it, but more broadly, you do think about repurposing and reusing conventional oil wells and facilities. So give us a broader answer to that, if you don't mind.
Yeah, I'd say really right now we're focused on existing geothermal wells. And some of the differences between a existing geothermal well and a oil and gas well is one, typically they're a lot more hotter, when we're thinking high temperatures, even in 250 C, 260 C. But the diameter is a lot different too. So we're working in a 9 5/8 inch diameter versus a 5-inch diameter, and that just restricts your flow when we start to deploy some of these other types of systems.
So the kit is not perfectly fungible. You do need bespoke kit, at least for some of what you're doing.
Correct, yep. But I think there's applicability, if you think about an oil and gas well, near the end of its life, depending on how briny the fluid is, you could just produce it with a electric submersible pump, flow a lot of fluid, re-inject it down and back in another well. It all depends kind of what you have to do at treatment at the surface for district heating, even for power use. But typically a lot of the oil and gas wells are lower temperature. They're not going to have as great of an efficiency once you get to the top side of the plant. But I think there's a tremendous amount of opportunity when we start to think more direct use, industrial heating type applications across Europe or even into the United States.
That's very interesting, and we'll come back to other technical points later if people are interested. But I do want to pivot toward thinking about the global scaling question, right? Because if you're going to get to that, anything like that 100x dream of scaling or potential that's been mooted, we're going to need to see this being not just an American revolution, but really a global revolution. And we saw a terrific graphic that Milo put up about the countries of highest potential and those just behind, with also medium potential, let's say. But what I read in your analysis, Rebecca, in the IEA report was that China, US, and India represent maybe 75% of next generation geothermal market potential. Is this going to be another game with just where we have a few winners and many laggards, or do you see the more kumbaya world that's posited by our friends here at Carnegie about where there can be a rising tide that lifts many boats?
It's a challenging question, especially when we're looking at weeks where tariffs and things around the world are being discussed. I think what's unique about geothermal, though, is it's not a commodity that you trade. Right? It is something that you end up using in your home, or you put into the grid, or you use to power your industry itself. And so I do think that the dynamics around geothermal are quite different. Within the perspective of the IEA has, in my opinion at least, some very unique convening power. And so I would actually be interested from the members of the audience and the members of this panel, or what are the roles that you see for organizations like the IEA that we can help push this discussion forward. So we have elements like the IEA's technology collaboration platform, and that ends up pulling together both public and private partnerships. But public and private partnerships, we talked about cats and dogs earlier. It's sort of like a zoo of different animals and species of what they can look like. And so what are the roles that we're looking for?
Well, let's turn to our practitioners here. When you think about, I know a couple of you are overseas. I think one of your companies is not yet overseas, although maybe you're thinking about it. When you consider international expansion, and the US is the leader in this field, let's be clear about that, but you think about the global potential, do you look for IEA partnerships, public-private collaborations, Or do you first go and look at, the basics of the geology and the talent or do you look at land rights, permits? Give us a sense of what matters to you. What would be helpful if we're going to talk about an expansion, and in particular, rapid scaling expansion? What are a few things that you'd like to see?
So maybe I'll start and then you guys can fill in too. So
And give us an idea of where you're operating, just so people know.
yeah, and we're not necessarily operating anywhere, but I think kind of to Milo's presentation is how do we export our technology to use it elsewhere in these other countries? So places like the Philippines, Japan, Indonesia, that's where we're working with several of existing operators that can use their technology in their fields today, get more heat out of the ground, get more power out of the ground. The USTDA was mentioned. That's another great vehicle on how do we take technology from the US, get these pilot projects stood up and running. So we're working closely with them and have in the past. How do we do that in places like Kenya or the Philippines and other places too? So the vehicle for us is more technology, bringing that to market with existing developers. Of course, we have our partnerships with Baker Hughes and Valorec, so bringing that supply chain, kind of your point, how do we provide a kit of technology so these developers can actually use it and grow their resource as well?
So is it fair to say you see the value in your IP and in licensing rather than as an operator going forward?
Yeah, I think it goes beyond just licensing too, but it's our intellectual property, but also to get these done correctly, so the risk is there for them to just kind of go do this on their own, right? But take what we've learned, take what we've done, help them through the process, whether we're managing the operation, deploying it, and then kind of handing them the keys as they keep the operations up and going, right? Or help them on the maintenance side. So kind of that framework is what we're looking at right now.
Right. Caity, how about you?
Yeah, and my perspective is as a non-geologist, so probably a little bit different than Rob's. I think that the charts that are in the report that Milo showed earlier are really key. While we are looking obviously for, yes, there's a great resource there, there also needs to be that political stability and some sort of avenue to actually get those development rights, get rights to the land, all of that, if you are actually wanting to go to be an operator overseas. And so countries that don't already have a strong regulatory framework that enables geothermal development are a little bit less attractive. And I can say, I was part of the team that helped Ethiopia write their geothermal regulations. It took a really long time. So,
And I think only 30-something countries have regulatory frameworks, am I right?
Yeah.
Even though many more have the potential to be geothermally productive.
Yeah, so I think that there's definitely some learnings that can be had there, and it would be a great way for the U.S., through be it the Department of Energy's International Affairs Department, something like that.
Does it exist anymore?
IA does still
Just
technically
checking. I never know.
exist.
You have to check every day.
Yes, I did not mention USAID, which used to do some great geothermal work in East Africa. But looking at, and by no means is the U.S. geothermal regulatory framework perfect, but we have been doing it here for quite some time. So taking some of those learnings and sharing them with some of those countries that don't yet have that framework,
Right.
and working with them, providing experts who can advise them on drafting and the things that they need to think about. I think that those are all really big opportunities for the U.S. to potentially partner with IEA or with other governments, to really be the world, because we are, for now, the largest producer of geothermal in the world, to go out there and say, let's help these other countries try and take over that position.
Lev, how do you see the picture?
So, several angles. First of all, I'm representing here, I'm minority here representing EGS community, okay? And the key to EGS community, we all rely on creating hydraulic fractures, okay? We can call it differently, but it is hydraulically fracturing,
So
okay?
in Europe, verboten, you cannot frack. Am I right?
No, you can, because hydraulically fracturing or stimulating for the purpose of producing water is not prohibited anywhere, Now, but you need to overcome people's concerns, right? It's working with communities. It's not legally prohibited, but it has negative connotation, okay? So you have to work with communities, okay? So when we select international geographies for expansion, we look at where fracking operations or hydraulic fracturing is more acceptable. That's number one. Number two, we are startup, right? We have to return to our investors. So the rate of return from the projects, and what I want to mention is, I don't know how many people know that in Europe, cost of heat or price for heat is like 10 times larger than the equivalent price of electricity. So you need to drill shallow because you don't need that much temperature, and now your returns potentially is 5-6 times higher. So now risk capital is available because of the level of your returns. So that's kind of number two where we are looking for the projects. And number three, liberal permitting regimes.
Before you go to number three, isn't there the discrepancy? I mean, you point out the premium for heat in European markets, and the price is much higher. Many customers in the US, even industrial customers who should know, don't actually know what the price of heat is.
Correct.
Am I right? So how
Yes.
do you monetize or get an investor to back something when the customer doesn't even know the price?
In the US it's very difficult because in Europe it's usually tied to district heating infrastructure. There is a very well-defined price structure. How many you're getting, I mean, there are same PPAs for heat, okay, than PPAs for electricity. In US, this market does not exist today.
Right. But that's a co-benefit of geothermal
Right.
that can't yet be monetized effectively.
That is
So we
correct.
may need to work on that.
Yes,
presumably.
absolutely.
Now your point number three.
The point number three is legal permitting regime. As Caity said, I mean, in many countries, or some of the country, permitting will take longer than my life expectancy.
We hope you live a long life.
Thank
But
you.
your point is well taken.
Right.
Yes, yes.
Can I jump in maybe
yeah, jump
just,
in. Yeah,
just
please.
really briefly, because I think it's important to go back to a point that Milo had started with on supply chains. And there's several elements around the North American supply chain, be the people, the rigs, but also the culture. And when we talk about, at least from an IA perspective, on the learnings transfer and the ability to drive down those costs, in many countries where there is geothermal, there is no oil and gas industry necessarily. Or if there is, the cost structure is significantly higher than here in North America. And so it is more than permitting. It's also how do you create an environment that invites those companies to move in. And so when they go between one country in the EU, I'm making this up, one country in the EU to another, that they don't have to go through an entirely different set of permits in order to move a rig from X to Y. So how do you set that environment up in order to allow not just the entrepreneurs to grow in, but also the overall oilfield services companies that are needed to enable all of this?
So there are a couple of things in what you said I wanted us to spend a minute on. One is in terms of the ease of licensing, and another maybe some international coordination of it we can talk about in a minute. Mm-hmm. But in terms of the ease of licensing or fast tracking, or the reverse of slow tracking, which is your experience, and in some countries, I understand in the US there was an effort over the years. For example, if you have an oil and gas license, you can move into geothermal without an onerous burden of reapplication waiting another 20 years. Is that an effective model for other countries to pursue? And relatedly, some people have suggested that there may be either lessons to learn from how mining licenses are done to emulate or to avoid. In the case of the US, I think it takes 25, 30 years to get a full mining license. And so maybe avoid going down the road of how mining is licensed. What can you say from the international perspective, and anyone that wants to chime in on those before we talk about maybe harmonizing going forward?
On the last point on mining licenses, I don't know that I can comment just because I know if we look at from a critical minerals perspective, we estimated I think around 16 years from the time that you're really starting that a mining opportunity is a gleam in the eye until you actually get things moving ahead.
So that's not a model we want to follow
that
in
is
this
not,
area.
because we will never get to 15% of geothermal in power generation by 2050.
Gotcha.
I want to add that I don't think there is one solution that fit all these scenarios. Like when we're in Texas, being regulated under oil and gas, it's huge benefit. If you are in California and you want to be permitted as an oil and gas well, it's not going to happen,
It's not going
okay?
to, right.
Yeah.
So I just gave you two examples,
I
okay?
see.
And internationally, there are similar situations,
I
okay?
see. I see.
Yeah. And I think, coming back to the mining example, yes, we don't want to go down that path on the development side, but if you look at the mining exploration process, you can go out and stake a mining claim and do geophysical data collection with very little work on federal lands. Whereas for geothermal, you have to nominate the land. BLM then has to decide that they're going to put it up for auction, do an environmental assessment. It goes to auction, you bid on it. You then go through multiple processes just to collect, magnetotelluric or gravity data, which no drilling rig. It's a group of people out there, putting some sensors on the ground. But they still require that you go through that NEPA process. Whereas mining uses a lot of those same techniques, and they do it all through the staking process. So, for the exploration point, I think there are things that we can learn from mining for geothermal.
Okay, so there are lessons. Rob, jump in on this.
Maybe I see you're eager to ask questions, maybe, or go around. But on the rig, kind of going back to the rig side of things, I guess even as a country, we just have so many rigs available to go do this. Even in California, there are some mobilization challenges, like Lev said, going from Texas to California, wherever we need these. But then as we start to get international, it's even more challenging. There's been a couple projects where someone said, well, if we, maybe we could work with the US and get a helicopter to kind of bring in this rig. And you're kind of like, okay, that's, maybe. And then the other one down in the Caribbean, it's like tremendous resource. Maybe we'll have to get a boat, we'll ship it here, we'll ship the rig, but that's just all these extra logistical challenges. It's not just, they may have a good permitting framework, but rigs and the prices of rigs, and then the people that have to man these are very, very expensive. That's even been a cost prohibitor on some of our projects that we've been looking at. It's just these rigs are expensive, the time you need to do this, but now you start to add getting a rig and mobilizing things, that just creates a cost control you can't
Just
handle.
add a wrinkle to that. You had earlier emphasized your company's proprietary technology and the licensing. I think every company probably closely guards its secrets. Especially with startups, because that's a big part of the value of your company, I suppose. But if we're talking about international collaboration, technology diffusion, especially a lot of developing countries that may lack access to those technologies or the resources to pay for them, how do we find the right balance between protecting that IP and accelerating diffusion in the way perhaps the IEA would like us to see? Any bright ideas?
Well, for us, we file a lot of our patents in all these different countries where we think either geothermal is, developing or going to be developing in the future. So making sure we have those right intellectual property patents filed, and then really working with those companies and structuring our agreements, right? Whether it's trade secrets or the data and information we're getting or how we're applying these in their field. So you have to safeguard those with who you're working with, but do the best you can as far as kind of licensing IP and what you're looking at internationally.
Now, a couple of you have mentioned DoD, Department of Defense, as a potential partner, supporter, maybe even the access to land, maybe fast tracking. And it does have, this technology has the advantage of resilience and domesticity, right? You take the heat underneath your feet, as it were, so it's by definition secure. But does that pose additional constraints on tech licensing or spreading of diffusion of knowledge? If you've got a DoD partner or a big relationship with the Pentagon and you want to go into multiple countries, are we going to have the equivalent of the NVIDIA chip ban or restrictions? Is there an issue here that anybody wants to speak to?
I think it's just opposite, actually, because the moment we get support from Department of Defense, international, and we announce it. Internationally, it's like golden medal, okay? So all due diligence has been done, and if US doing something, Department of Defense, we probably need to look at it and probably also have to invest, okay? So it helps. Now, on your previous question about IP, our strategy, we're the team who developed and commercialized a lot of oil and gas technology over 30 years, and strategy for international expansion always was go fast, okay? Market is so big that we are not actually concerned, okay? There will be competition, but we are fast movers, we capture markets, and then we internationally, we license, we partner, okay? It just, market is unlimited.
How is China as a competitor in this space, given we know their advantages in solar, PV, batteries, and numerous other green technologies? I've heard tell that they are quite interested in this area, and including using for industrial heat, for example. They may be in the world lead in that application of it. Could it be that we'll have another global race between the US and Chinese companies, or is there capacity and development not at the same level as US technology? Someone have a view?
Go ahead.
I was gonna say, I don't think that they are, China is not where the US or Turkey or Kenya or some of the other countries are, or New Zealand, for geothermal power development. You know, district heating, industrial heat use, totally different story. But you know, I think right now as a larger industry, we're not overly worried about China coming in and taking over the markets on the next generation geothermal electricity front.
You have visibility on China from your perch in Paris. What do you think?
I don't see, you know, from where I'm sitting and what we've looked at, there's not a natural race in this space.
So it's not like in solar or EVs or anything like that.
No.
The game is different here.
I think the race is at the critical mineral level
Right.
and building up.
Sure.
And then when you come to geothermal, you're using a lot of those materials. So I think that's where the focus is rather than on
Okay,
geothermal.
well, for those of you American dominance, America abundance boosters, there's some good news. There's an industry where America is in the lead and could indeed lead the world to a greener future. And recent political bipartisan support seems to suggest this might be possible. As we're coming close to the end of our session, I'm going to have a quick lightning round for my panelists. In reverse order, we'll come back. In one sentence, how would you answer this? If we were to hold this gathering in 2035, what do you think will be the biggest success in advanced next generation geothermal that you will be trumpeting or that the world will be celebrating? We'll start with you, Rob.
Yeah, I didn't know the question was coming, so I get to
Hey man,
go
the
after
future
it
comes
first,
at you
but-
fast.
But maybe even more beyond, one of the big ideas I guess I see is how Asia Pacific in particular has just tremendous resources. I was disappointed that geothermal didn't get its own hydrogen hub, but if you think about islands in the Asia Pacific where nobody lives, you know, they don't have a population, but they may have there's tremendous resources all over there, how they could actually be exporting geothermal globally kind of out of that region to other places
All right,
of the world.
that's a provocative vision. I'll call it the Krakatoa vision, but go on. Okay, Caity, let's see what you got.
Yes.
One sentence.
Yeah, so 2035, you know, I think I would love my talking point to be that XGS has well over a gigawatt of geothermal power installed here in the US and even more overseas, which, you know, anyone who follows geothermal knows that timeline for that much electricity is unheard of.
They say that your first gigawatt is the hardest, so from there
we
onward to
go.
10 and 100. Right, Lev, what's your 2035 prediction?
That's my kind of passion and obsession. We'll have super hot, super deep in the ground, generating electricity below 4 cents per kilowatt hour.
Wow, okay, that's pretty deep, and you're going to hear more about it in the next session, so thanks for teeing us up. Closing word to you.
I think we're sitting at 1.5 investment cycles, you know, out from 2035. So we have some opportunity to cycle and be able to learn, but not a lot. And so if I just step back, I want to see all of the enablers that we've talked about today really starting to frame up in place. So the regulatory frameworks that Caity was talking about, the standards discussions in terms of around supply chain, oil field services, how we move those around. That's really what I want to see, probably a lot earlier than 2035.
Okay.
To enable Lev's 4 4 cents quote.
Great. Just a final word of inspiration. At MIT Enhanced Geothermal Systems report, published in 2006, said the following: the Earth's interior is not a cold, dead place, but a dynamic, churning engine of unimaginable power. Every second, our planet radiates more energy into space than all of human civilization uses in a year. The question is not whether we can tap this power, but whether we're wise enough to do so. So we challenge our innovators to show us that it can be done, and our policymakers in the room to help them to do it. And let's come back in, if not 20 years, 10 or even 5, and see how far they've gone. Please give them a nice round of applause. Thank you. I turn it over to Milo.
Fantastic. Thank you all for the wise words of wisdom. I just want to tell our audience kind of brief run of show and some exciting recent developments. The Kenyan Embassy has just announced that they as well will be speaking on our final panel of the day at 4:20. As I mentioned, Kenya is a geothermal champion and leader. We are so honored and thrilled to have them in the room. Right now, lunch will be served for you all, and then we'll be hearing from Lauren Boyd, the lead at the U.S. Department of Energy's Geothermal Technologies Office, hearing about super hot rock, and then we'll come back for the diplomats to talk about an international perspective. Thank you so much, and enjoy the food. Vijay, you were exceptional.
Thank you. That was fun. Great.
Really excellent job. Thank you,
Thank
Vijay.
you. You were my star.
Thank you very
Thank you.
much.
That was fun.
No,
Thank
I
you,
mean,
Katie.
Milo,
It
how
was
do we
great.
come after you? Because you were
Thanks.
amazing.
Fantastic.
Really, very well done.
Thank you.
It was fun.